Here's an example I had to work very hard for. Find the volume of the solid region Q cut from the sphere of radius 2, x squared plus y squared plus z squared equals 4, by the cylinder given in polar coordinates r equals 2 sine theta. That would be for all z, so it's like I took the circle r equals 2 sine theta and projected it along the z-axis. Notice from my very difficult to draw picture that right here, actually right here is where the origin is, and this is not drawn properly. This is not the x-axis, this is not the y-axis. The x-axis and y-axis would be here in the center. Actually, it almost looks like it is drawn properly. And so, let's see if we can tackle this problem. You can't think of this as in the back. You have to think of this pole as going through the center. So maybe it's the z-axis that's misplaced. But almost, if it does look like it's drawn accurately, it was an accident. A happy accident. But instead of saying x squared plus y squared plus z squared equals 4, we're going to change that to r squared equals 4. And so then we can get our z limits fairly easily by saying, solving this for z equals plus or minus square root of 4 minus r squared, so there's our z limits. The r and theta limits we can find by looking at this region here, which is in the xy plane, which is up here. That's the way you graph r equals 2 sine theta as a circle that passes through the origin of radius 1. So here would be our integral. The r dz dr d theta is our volume element. Z limits going from here to here. R limits going from here to here. If you think about drawing a stripe across this region from the pole, it hits at 2 sine theta, and in the inside would be at the pole. And you can start drawing these out through the origin at theta equals 0 and stop it at theta equals pi. So you can probably see why that's correct. So when we integrate this with respect to z, we just get z, and z going from square root of 4 minus r squared to negative square root of 4 minus r squared would give us square root of 4 minus r squared minus negative, so plus square root of 4 minus r squared, or two of those things. Then we want to integrate times r dr d theta. A few things to comment on. If u equals what's under the radical, and du is negative 2r dr, and that will make this integration come out pretty nicely. I'm going to substitute for my limits as well. If r equals 0, then u equals 4, and if r equals 2 sine theta, then 4 minus 4 sine squared theta would be the same as 4 cosine squared theta. That simplifies that limit a little bit. And the du over negative 2, the 2 cancels with this one, so we still have the negative in there, but then again we can switch these limits of integration around and take care of that negative as well. So now our integral has become ever simpler, and hard to think of a simple one is not on the page. Another thing to notice is the symmetry of our region. We could just integrate from 0 to pi over 2, our 2 square roots of u du d theta. And so integrating square root of u, we get 2/3 u to the 3/2. So our integrand comes out, our integral comes out 4/3 u to the 3/2. The 2 that was already here plus times the 2/3 gives us 4/3. Evaluated between 4 and 4 cosine squared. So throw in the 4, we get 4 to the 3/2 is 8, so 8 times 4 is 32/3. Throw in the 4 cosine squared. 4 cosine squared to the 3/2 is 8 cosine cubed. So we get 32/3 cosine cubed d theta. So now what are we going to do? Well, when we have a odd power, we can make cosine squared times cosine and replace the cosine squared with 1 minus sine squared. Now that will make things kind of handy, because now when I want to integrate this part, I can just say let u equal sine theta and du. There it is, cosine theta d theta. So that would be perfect chance to look at, and we'll get an answer of u cubed over 3. And the over 3 makes that a 9. And integral of cosine is sine, so we got 32/3 theta minus 32/3 sine theta plus 32/9 times sine cubed theta, evaluated between 0 and pi over 2. If we put in 0, everything here is 0, so that's nice. When we put in pi over 2, we get 32/6, call it 16/3 pi. We get 32/3 times 1 plus 32/9 times 1 cubed, which is still 1. So we got 16 pi over 3 minus 32/3 plus 32/9. I guess if I were to say what that simplifies to, make this one 96/9, and so we get 16 pi over 3 minus 64/3. Oh no, I'm sorry, 64/9, right? Because this is negative 96/9, and then plus 32/9 makes it negative 64/9. As a number, comes out to approximately 9.6 blah 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 blah. So that seems a reasonable answer for our volume of this thing. Remember, the sphere has radius 2, and we're going right through the middle of that. The entire sphere, I guess, would be 32/3 pi, and we're substantially reduced from that. Whoops, I went too far. Sorry. Yeah, substantially reduced from the 32/3 pi, so I hope that answer is pleasing. For what it's worth, I could go back to the first place I had that integral drawn and see, let my software do it and see if I get the same answer. Happy day.